Okay, so I'm going to start off with the problem set 2, alternative problems. And so we're going to start off with question 1. So I'll read it first. So it is the following ESI-MS spectrum in positive ionization mode for PPAR gamma is obtained. Using the M over Z values for species Y and Z, calculate the molecular weight of the PPAR gamma protein to 5 significant figures. So these two proteins we can see through this MS that they give you. So we're supposed to look at Y and Z. So this one is 828. So M over Z and 848 around that, M over Z for Z. So the reason why this one is lower, so ideally all of these X, Y, and Z, they all have the same molecular mass, but they have different charges. The reason why, which is Z, the reason why Y and X are lower than Z is because their charge is higher. So for an example, Y has a greater charge than Z and X has a greater charge than Y. Does that make sense to you guys so far? Online? Thumbs up. Okay. I guess it does. Okay, so basically, because you guys haven't learned MS yet, so I'm going to try to go little by little to help you guys understand this. So that is what we're going to use to answer question 1. So our Z value for MZ is 848.88 equals to M plus Z over Z. So the M is the mass, the Z is the charge. For Y, it's going to be 828.69 equals to M plus 1 plus Z over Z plus 1. So the reason why we're doing plus 1 here and not plus 1 here is because when you look at this, you see that Y has a greater charge than Z. That's because it's one peak away from Z. So this one, so how you know that the Y has a greater charge than Z is because, as I said before, the charge, the MZ is lower here. So if this has over 1 plus 1, then it's going to be a lower value. While this just has 0 ideally, then over 0 is just going to be a greater value. Okay. So going back to the problem. So what I'm going to do is use Z, and I'm going to do M plus Z over Z equals to 848.88. And then M plus Z, 848.88 times Z. So you move this Z onto the right-hand side. And then I'm going to subtract this Z, and I'm going to get 847.88 Z equals to M. So I'm going to use this equation, which we got from our Z, and I'm going to substitute it into this Y equation. So I drew a little arrow here. So Y is equal to 828.69 equals to 847.88 Z plus 1Z over Z plus 1. So this one comes from our Z equation. And so I'm going to do 828.69 over 848.88 Z. I'm going to add this Z to this Z and get this plus 1 over Z plus 1. And then I'm going to get 828.69 times Z plus 1. I'm going to move my Z plus 1 over to the left side, and it's going to be equal to 848.88 Z plus 1. And then I'm going to do 828.69 times Z plus 828.69. So I'm going to distribute this 828.69 and get this, and then just leave this there. And then for the next step, we're going to do 828.69 Z plus 828.69 minus 1, and that equals to this. And so then I'm going to bring this Z over here, and I'm going to subtract it, and then I'm going to just basically get the Z out here and then just multiply it by this, and it still equals to 827.69. I cannot say my numbers today. Okay, and then it's going to be equal to Z equals to 827.69 divided by this. So we're going to isolate the Z. You guys can see it, sorry. Okay, so we're going to isolate the Z, and we're going to get Z equals to 41. So the M is going to equal to 847.88 times 41, which is the Z charge, equals to 34,800 dA. And so basically this charge, this 41 charge that we got is for the Z protein here. Okay, and so we know that since Z is like a higher number for M over Z, it's going to have a higher charge, a higher Z for Y. And since it's 1 peak away, it's going to be 41 plus 1, which equals to 42. Does that make sense to all of you guys? Or is that confusing? Okay, I guess it does. We'll keep going. Okay, so for question 1B. Okay, using M over Z values, calculate the charge of species X. So 34,800 daltons, which we got from 1A just now, plus Z over Z equals to 791.10. So this 791.10 is the value of X. And we don't need to do like +1 or +2 like we did for the Y in 1A, because we're just trying to figure out the X here, so we don't need to like input it in a different equation. And it's equal to the exact value of X. So basically what we're going to do is 791.1 times Z equals to 34,800 plus Z. And then we're going to bring this Z over to the left side and we're going to subtract it by this. And it equals to 34,800. So basically what we do is we just do basic algebra and then we isolate the Z and divide 34,800 by 790.1. And we get the Z is equal to around 44 for the species X. Okay. And then for 1C, the question is, what would be the spacing of the isotopic peaks of species X? So this is simply just 1 over Z. So it's 1 over the charge, which we figured out here in 1B for the species X, which is 44. So you just do 1 over 44, and that equals to 1 over 44 M over Z units. Don't forget to put that. And then, okay, we're going to move on to 1D. So what is the approximate number of residues in the PPAR gamma protein? So 34,800 daltons over 110 daltons equals to 316.4, which is about 316 residues, and residues are also known as amino acids. So what we have to know in this problem is that the average residue weight is 110 daltons. So this is kind of like a constant that you guys should remember for the test. So that is it for problem 1, and now we're going to move on to problem 2. Okay. So, and the people online, if you guys have like any questions, just like holler them out because I cannot see the chat function. So for question 2, 3 peptides were synthesized and the researchers wanted to confirm their sequences using mass spectrometry. The first peptide is LDARGETY. And just remember, you guys, to memorize your amino acids. I'm sure you have because you're finished with your first exam. And just remember the charges and just hydrophobic, the hydrophobic or hydrophilic. And then, okay, so please draw the structure and indicate the different possible Y and B daughter ions that may result from running tandem MS-MS on the structure. So what is the sequence of the Y and B daughter ions that may result from running tandem MS-MS on the structure? What is the sequence of the Y7 and B1 ions when the pH is 7.4? Okay, so this is basically where you have to draw a structure, a peptide structure, like we did last time in problem set 1. You guys remember we did it in problem 7, I guess. So this is basically the amino acids that I used, LDARGETY. So what we do is we draw the whole structure out, and this is amino terminus, of course. Don't forget to add that in on the left side. Always peptide chain always starts with an amino terminus, and then it ends with the carboxyl terminus, which is always on the right side because the peptide goes from left to right. Okay, So what we do is we cleave. You guys have to find the peptide cleavage and draw this little mark where the first peptide bond is. So ideally where the first carboxyl and amino group meet. So I drew it here. And so the B1 ions basically extend from the amino terminus, and the Y7 ions extend from the carboxyl terminus. So why I highlighted this was because this is like the first B1 group, and this is the Y7 group. So does that make sense to everyone? Any questions before I move on? Okay, I'm gonna move on then. I made a little note here, so you guys can see. Okay, I'm gonna move on to question 2B. Okay, this one is a long peptide. So okay, so the second peptide, I'm not going to read that, is cleaved by the reaction with thrombin. Thrombin is a serine protease that hydrolyzes peptide chains at the carboxyl side of the amino acid arginine. Then the products of digestion are subjected to ESI, TOF, MS in ion mode with the peptides in a pH 2 solution. What peptide fragments will result and what are their MZ values? So in class, I know you guys haven't gone to lecture after your exam 1, but you're gonna have to memorize like the different peptide cleavages like trypsin, chymotrypsin. So we're using thrombin. So in this case, thrombin I will have to cleave it at the glycine and arginine side for the peptide here given to me. So I have done exactly that. So the first one is ASVHR. R is arginine. And then the second one is, here, let me just try here. Okay. So ASVHR. So we know that R is arginine, and then G is glycine. So I'm going to cut it here. And then the next one is going to be GVTSAHILTAVDSIVRG. So it cleaves here again because arginine is here, and then glycine, and then HF. So we have 3 little sequences. Okay, so this is ASVHR, the one that I cut first, and it has 5 residues, 1, 2, 3, 4, 5. Remember, 5, the residues is another word known for amino acids. And then we have a +3 charge from the N terminus at the beginning, and the H, which is histidine, which is a base, and then R, which is arginine, which is a base also. So we know that H and R are going to be protonated at a pH of 2 solution, and N terminus as well, and that H and R are positive values, +1 each. So we're going to do mass equals to 5 times 110 Daltons equals to 550 Daltons. And then we're going to do M over Z equals to 550 Daltons over the +3 charge that we got here from this peptide. And it's going to be equal to 183.3. And then the next one here, this one is a little long. It's going to be 15 residues and a +3 charge from the N terminus, the arginine, and the histidine as well. And we do have a D amino acid, which is also known as aspartic acid, which you guys know that it is -1 charge, but it's going to be neutral in a pH of 2 solution because it's going to be -1 + 1 because the pH is acidic, so it's going to be 0. So then we look at the mass, and we're going to do the 15 residues times 110 Daltons equals to 1,650 Daltons. And then it's going to be equal to M over Z, which is equal to 1,650 Daltons divided by the +3 charge that we got from our peptide sequence here. And it's equal to 550 for M over Z. And then for the third one, okay, so the third one is going to be GHF, which is glycine, histidine, and phenylalanine. So it's going to be 3 residues because there's 3 amino acids, and the +2 charge because of the histidine, H, and the N terminus. And then the mass is going to be equal to 3 times 110 Daltons equals to 330 Daltons. And then the m over z is equal to 330 Daltons divided by the +2 charge that we got from this GHF, and the N-terminus as well. And it's equal to 165. Okay. And so for 2C, for the products of the digestion in question 2B, which product will reach the detector first? Explain why. So when we look at these, when it asks us a question like that, we have to look at the MZ value. So we see 183.3, 550, and we see 165 here. So when comparing the 3 peptides that we cut, the cleaved peptides, we see that the GHF has the lowest M to Z value, which is 165. So the peptide GHF will reach the detector first due to it having the smallest M over Z ratio. And of course, like the last peptide that will reach the detector will be the one with the highest M over Z value. And then for 2D, okay, so the peptide, this one is digested with trypsin. Then the products of the digestion are subjected to ESI, TOF, MS in a positive ion mode with the peptides in pH2 solution. What peptide fragments will result and what are their M over Z values? So it's going to be MNQSYGR, like the last one, we're just going to cleave. So it's going to be, here for the trypsin value, it's going to be arginine over cleaved with leucine, wherever that site is. So it's going to be 7 residues, which is amino acids here, and then the +2 charge. So this is from the N-terminus. Remember, it's protonated solution, page 2, and it's going to be from the arginine here, which is +1 also. So the mass is going to be equal to 7 residues times 110 Daltons. Remember, the 110 Dalton once again is like the average that I told you guys to remember, average residue weight that I told you guys to remember for this test and for your MCAT and what other tests, academic tests, healthcare profession tests you guys are going to be taking. So M over Z equals to 770 Daltons over the +2 charge, which is equal to 385. Okay. Move on. And then the second site that we cleaved at, well, it was the same site we cleaved at, but this is the second peptide sequence, which is LVSR. So 1, 2, 3, 4, which is 4 residues, also known as amino acids, with a +2 charge from the N-terminus and the arginine, which is +1. And so the mass is going to be equal to 4 times 110 Daltons equals to 440 Daltons. So the M over Z value is going to be equal to 440 Daltons divided by the +2 charge, which is equal to 220. And that is it. Does anyone online have questions? Or is everyone good? Thumbs up. Well, then I think you guys are good to go if you guys don't have any questions. I know this was a little confusing because you guys haven't learned MS yet, but I tried my best and I hope you guys understood somewhat of what MS is before your first class starts after exam 1. And I think we are good. Unless if you guys have questions or want to email me, you can do that. But I guess that's it.